Hello, welcome to the world of SICAM applications. In this video, I will give you a glimpse into the SICAM PPC Compact, the Siemens Light, and a competitive solution for photovoltaic power plant control. I will provide you with an overview of the PPC, discussing the architecture and main components. We'll go through the go-live requirements, specifically the hardware and minimum software requirements you need to operate such a solution, and the license order procedure. SICAM PPC Compact is an integrated solution for control and monitoring. Our goal is to deliver a solution that is easy to set up, with quick parameterization and fast commissioning. The solution is designed using the SICAM Device Manager and is engineered to cover up to 22 control units, including either inverters or smart loggers. It is licensed and typically targets power plants up to 50 megawatts. As you see, the solution is compact. The solution provides a competitive price, combining the CP8031 with SICAM Web HMI as basic features. We include measuring and monitoring using an integrated web UI, allowing us to provide measurements from the POI, point of interconnection with the grid. Through a power meter, we can display information on inverter production and inverter status. We perform generation control at different levels: active power control, reactive power control, and logging and archiving, using the standard capabilities of the SICAM A8000. Let's go through the details. Active power control includes MPPT control, where we aim to harvest the maximum power available according to current conditions, while ensuring that ramp rates are maintained. We also have an active power limitation mode, where the power plant controller limits inverter production according to the restrictions imposed by the operator. Additionally, we offer various reactive power control modes: pure Q control, reactive power control at the point of common coupling or point of interconnection, voltage control, tangent phi, and cosinus phi. Our system supports grid stability functions, including frequency response control. All these features are pre-configured, and we offer a customizable dashboard, an online testing function, and an integrated web UI for parameterizations and configurations. For operation, we provide a process data archive, event alarm management, and an interface with external supervision systems such as SICAM SCC if needed. Our hardware is robust and flexible, built on SICAM RTU CP8031. It supports a wide variety of protocols and I/O modules. Hardware replacement is very easy by just swapping the flash card with the whole configuration on it. Our control functions offer a simplified overview. In the center of this diagram, you can see the control modes. We can differentiate and operate in parallel between active and reactive power control modes. These modes regulate the power delivered at the point of common coupling, and this regulation is achieved by monitoring the power flow with dedicated energy meters that are also a part of the solution. We integrate auto-start functionalities and grid code or grid stability functions. The control modes operate independently on active and reactive power control loops, and set points are shared using a load-sharing mechanism that distributes power production needs across the inverters. As previously mentioned, we can support up to 22 inverters or data loggers and up to 50 megawatts. Now, let's explore the architecture. This solution begins at the process, focusing on what we are controlling and monitoring. In this case, we concentrate on 4-volt type converters while also integrating power meters, weather stations, and potentially protection devices, all using standard communication protocols such as Modbus, IEC 104, and IEC 61850. The controller runs on a CP8031, but we can also operate this control logic on a CP8050 or as a software-based solution, basically using SICAM 8 platforms. However, the controller includes not only the logic and the communication protocol that enable it to interact with the process and remote supervision systems, but also the integrated SICAM Web HMI or dashboard. SICAM SCC is available as an option, acting as a standard or generic supervision system that can be integrated, but it is not included in the standard solution. Moving on to the minimum hardware requirements, in order to control a power plant, we will always need to control inverters. These are essentially the muscles that we interact with to influence the power being generated by the plant. In this regard, we currently support Keiko and Siemens Gamesa. Of course, we can also integrate generic inverters as long as they support standard communication protocols. In addition to control, monitoring is also essential. For that purpose, we need to integrate at least one power meter. This power meter must be quick and accurate enough to align with the desired response of the photovoltaic PV plant. Moving one layer up, the controller itself, as I mentioned before, can run on CP8031 as well as CP8050 will only be supported with the next service, Pack 2, functioning as a SICAM RTU. Optionally, supervision systems can also be integrated. For example, I've shown SICAM SCC in a grayed out area, but it could be any kind of supervision system, such as a customer control center. In terms of software, the solution itself does not require any specific software to run. However, to engineer it, we use SICAM Device Manager, which is currently at version 4.4. Licensing overview. SICAM PPC Compact is, in fact, a SICAM application. It utilizes SICAM devices for implementation. As part of its development, we have created specific function blocks to handle power plant control and integrate drivers and functionalities. Some of these function blocks are protected by a license. This means you will need a license to access the runtime of the system. When you purchase the license, it includes SVG graphic templates for use as a dashboard and RTU configuration templates compatible with SICAM Device Manager. License details. SICAM PPC Compact is designed to cover systems up to 50 megawatts. There are two levels of licensing, one for systems up to 5 megawatts and another for systems between 5 and 50 megawatts. The license's cost is determined by function points. PPC Compact up to 5 MW costs 140 function points. PPC Compact 5 MW to 50 MW costs 400 function points. To manage licensing, you need a SICAM Function Point Manager budget account. By creating this budget account, an MLFB is assigned to the corresponding user account. You can then order a specific number of function points into your budget account. These function points can later be exchanged for licenses. For instance, in the example shown, I logged into my SICAM Function Point Manager budget account, where I had a certain number of function points. I generated a license for a device by inputting the device serial number and selecting the device type, in this case, CP8031. I also added optional customer or internal notes to keep track of the license details. Then, I chose the license type, for instance, a photovoltaic plant control license for 5 megawatts, costing 140 points, or 50 megawatts, costing 400 points. After selecting the license, I generated a file, which could later be imported into the controller. Licensing and customization. The PPC license can be generated using the Function Point Manager wallet. This license can then be imported into your device to enable the PPC Logix operation. Along with the license, you will receive a backup of the SICAM Device Manager project, which can be customized according to your specific project needs. We will demonstrate the customization process in upcoming videos. At the end of the process, you will have a system capable of coordinating the operation of your inverters while enabling safe and reliable grid connection. It will also allow you to comply with grid codes, restrictions, and operational requirements. Thank you for your attention, and see you in the next video.